I'm Mr. Harris, and this is Similar Triangles. Alright, so the why here, we talked about some of this before. We're looking for patterns. And we're looking for relationships. And we're going to identify and manipulate these relationships to help us solve problems. Okay, so we've got some more similarity postulates, similar to the congruence postulates, except in this case with similarity we're looking for an equal ratio. Alright, so let's go ahead and dig in. Okay, start with what we know, vertical angles right there. Okay, so I have the A. So if I had to guess right now, it's looking like a side angle side. Now, I don't know if you can see this right away or not, but when you rotate this one to get it to match up with this, these two are going to match up. And in a similar matter, this is going to match with that. So what we're doing is going to see if the ratios are consistent. Okay? So we got little over big or big over little. Okay, 24 to 16. Is that the same as 18 to 12? Can we reduce both of those things? I'm going to reduce this one down here and put 8 into each of them, and it looks to me like that's 3 over 2. And then I'm going to look at this and I'm going to put 6 into each of those, and that looks like that's 3 over 2. So the ratios are equivalent. Alright, so we have two equivalent ratios of sides, and we've got an angle in the middle, so that is side angle side. Okay. Number 2, this is kind of a tricky one in the sense that it's not just these two that we're looking for. We also have this one from yesterday, right? So do these triangles, because I don't see anything with the sides, so I'm going to have to move on from that. This angle is the same in both triangles, both the little triangle and the big triangle. So that's going to be angle angle. This one right here with 3. You have the lengths of 3 sides here, you have the lengths of 3 sides here. You should just be able to look and see that, you know, 5 to 8 is the same as 5 to 8 is the same as 5 to 8. So that's yes, because of the ratios are consistent. Okay, that's what we're looking for with the similarity, and that's what we get when they are similar. We get consistent ratios, okay, which can help us solve problems. Over here, I've got an angle, and then it looks to me like good ratios, except I'm going to take one more look at where the sides are, because we had a nice term when we talked about side angle side congruence, and that word was sandwich. And that's probably spelled wrong, so I'll go ahead and underline that. Sandwich. Is the angle sandwiched in between the sides? For side angle side, is the angle sandwiched between the sides? And clearly here the answer is no. Okay, so you have SSA or ASS, which we all know that doesn't work. So I'm going to go ahead and put put no right there. One of the nice problem-solving skills that some of you showed on the last chapter test is to draw a picture or redraw a picture. So I would choose to draw this littler one so it looks like that, and I get something like that. It doesn't have to be perfect. And then I'm going to match up the sides. 12 would be here, 15 would be here, and 21 would be here. So then it's the same thing I did here. Big over a little. Big is 20. Little is 15. Big is 16. Little is 12. And big is 28. Little is 21. If I reduce all of those, 5 goes into this, 4/3. 4 goes into that, 4/3. 7 goes into that, 4/3. Those are all consistent. So that is side, side, side. Again, for similarity, we're looking for consistent ratios. They don't have to be equivalent, but we want them to be consistent. Number 6. I've got, it looks like, if we did that with congruent side angle side, and 6 and 24, 16 and 24 are some kind of ratio, but 20 over 20, because those are the same, I was like, maybe that will, well, 20 over 20 is 1. And however you slice it, 24 over 16 does not equal 1. So even though there are sides and there are ratios, the ratios are not equivalent. So that is a big fat. Okay, the ratios have to be equivalent. All right, let's kick it down. Okay, and I want to see if I can get all this in here. That looks pretty good. And here's where I like to use problem-solving strategy. Draw a picture, notate, or whatever you want to call it. So I'm just going to fill this in. M is Q, and Mn over QR. So these sides are going to, so I'll just put those sides are going to be similar, because it doesn't tell me what they are, but it says the ratios are going to be equivalent to MP over QS. So I would have that side too. So that angle is sandwiched or included, so that would be side angle. Okay, hopefully you have an eraser. And if you don't, just redraw the picture. That's why it's nice to have an eraser, because you can start from scratch, get a fresh look. P is S and N is R. P is S, N is R. To me that looks like angle. Ready to tear it down again. MP, QS, side 1, MN, QR, side 2, those are the same, and NP and side 2. So that's going to be 3, right? Use whatever notation you want. You should see that you have 3 equal ratio sides. So, oops, a little private email there. Just close that off. All right. So let's bump it down here. Side angle, side similarity. Okay. What are we doing here? Alright. Oh, we know it. The problem says J is F. So let's notate. Let's draw a picture. Let's label. You know information. I know it helps me to write stuff down. I'm old. I forget stuff. You guys, you're much more on it than me. So it's a good habit to get into. Side angle sides. So I would say that we need to get, this side, those sides, so we get that angle sandwich. So I'm going to go in order: HJ and EF, and JG and FD. Alright, and I think I can leave it up. Angle. So if we want another angle, we just do angle G and angle D, and then there's another choice too. We could say H and E. Angle H, angle E. Alright, that's good for today. We're coming up against 12 minutes, so hope that makes sense. We'll practice this and keep working on this, so please enjoy the rest of your day, and we will speak with you soon.